Hello students, welcome back to the sixth video of this playlist. So in this video we will be solving question number 6 from May 2024 P1 regional paper. So let's see what's the question number 6 it's about. So basically the concepts behind question number 6 it's from chapter number 6 and 7, that is trigonometry, that is chapter number 7, and radians chapter, that is discussed in chapter number 7. Chapter number 6 is trigonometry, chapter number 7 is radians of your P1 textbook. So in order to be able to solve this question, definitely you have practiced sufficient questions from chapter 6 and 7 of your P1 textbook. So let's get started with question number 6. So here you can see a figure 1, which shows a sketch of the entrance to a tunnel. Okay, so the shape of the entrance consists of a sector BCDF of a circle center F joined to two congruent identical triangles ABF and EDF. ABF and EDF are congruent. That means these two triangles have the same length and same angles. Okay, so given that what's given, AFE is a straight line. You can see AFE is a horizontal straight line. AF equals to FE. AF equals to what? FE, that is how much? 6.4 meters. Okay, both are 6.4. FB equals to FD. FB equals to FD, that is 6.2 meters. This one and that one both are 6.2. Fine. Next, angle BFD, this is 2.275 radians. BFD, what is BFD? This one is basically BFD. This is 2.275 what? Radians. Fine. So part A, they are asking to show that angle AFB equals to 0.433 radians to 3 decimal places. Okay, we need to show that angle AFB. Where is angle AFB? This is angle AFB, right? So we need to find out the angle AFB and show that this is 0.433 radians. So we know that here AFB and DFE both are equal, right? If this is theta, then this is also what? Theta. Fine. So that means, and again AFE is a horizontal straight line. That means its angle is what? Pi radians, 180 degree, isn't it? So what we can write for here, part A, like twice of angle AFB plus 2.275 radians, this is equals to pi radian. Fine, because both the angles are equal, so we can write twice of AFB. Okay, so from there we need to find out the angle AFB. So twice of angle AFB equals to what? Pi radian minus 2.275 radian. Okay, so angle AFB would be what? AFB equals to pi minus 2.275, so 3.1416 minus 2.275 over 2. So this is basically 0.4333. Okay, this is basically 0.4333 radians. So which can be written as 0.433 radian up to 3 decimal places. That's it. Done. This is part A. Part B, they are asking to find the perimeter of the entrance to the tunnel. Perimeter means what? The border length, right? The length of the border, okay, of this tunnel ABCDEFA in meters to 1 decimal place. To 1 decimal place. Okay. Now most of the students do a mistake here. They consider the whole, all of the sides, the length of all of the sides, and also the border. No, for perimeter we will just consider the border. Perimeter means what? The border length. So what's the border length here? AE AB, DE, and BD, the sector B, the arc BD. So this is the border. Just consider the border length. So how can we find out the border length? Look, we know 6.4 here. 6.4 is known. This is the length of AF. 6.4 is what? AF, and FE is also 6.4. So the length of AE is what? Twice of 6.4. Okay. Next is we need the length of AB and BD. AB and BD, these two lengths are unknown, right? So length of AB, again AB and DE are basically equal, so we need to find out any one of them. Okay, that's it. And we need the length of arc, what? BD, it's also unknown. So our first work is to find out the length of AB. Okay, so to find out the length of AB, let's see. We know the theta, that's just we found in the part A. We know the length of the two adjacent sides, right? We know the value of the theta. We know the length of the two adjacent sides of theta. There is 6.4 and 6.2, right? So we can easily find out the length of the opposite side of theta using what rule? Cosine rule, right? So cosine rule says that if this is A, this side is B, and this side is C, then cos theta on the right side, cos theta equals to what? The sum of the squares of the two adjacent sides, so a squared plus b squared negative c squared over twice of ab. Okay, so this is the cosine rule that we will be using. So from cosine rule you can make like c square subject, right? C square is basically the opposite side, AB, that we need to find out. So you can make c square the subject and form the equation like this. For part B, length, we need the length of AB. So length of AB, so at first what? AB squared. So AB squared is equals to what? The sum of the squares of the two adjacent sides, that is 6.4 squared plus 6.2 squared minus twice of the product of the two adjacent sides, and then times what? Times cos 0.433 radians. Fine. Okay, now just find out the value for AB. We need the length AB, right? So AB would be what? Square root of what? Find out the value. So keep your calculator. Don't forget to keep your calculator in radian mode while you do the calculations using calculator. So 6.4 squared plus 6.2 squared minus 2 times 6.4 times 6.2 times cos 0.4333 radian. Okay, I'm taking the exact value to get the exact answer. So we are getting 7.374. that is the value for AB squared. Okay, this is the value for AB squared. So this is square. So AB would be what? Square root of 7.37 something. Okay, it keeps going. So that much meter. So the value of AB is square root of answer. You will get 2. I'm writing the exact value. 2.1. Sorry, 715519113 meter. This is the length of what? AB. So AB and I think DE, AB and DE are equal. So we got the two lengths done. Now our next step is to find out the arc length, what? BD. Yes. So we need the arc length, what? So arc length BD, this is equals to what? R theta, right? What's the radius there? 6.2 meter, right? 6.2 meter is the radius. Okay, so R is 6.2 and theta is how much? 2.275 radians. This is given in the what? Question. Okay, so 6.2 times 2.275 radian, you will get 14.105 meter. Done. Now we just need the perimeter, so we will just add them up. So perimeter would be how much? 14.105, okay, plus what? 14.105 plus 2.771, this keeps going, times 2, because the two equal lengths, right? Plus what? The length of AE, right? AE is 6.4 times 2, and AB we got 2.715 times 2, because on the other hand it has another equal side, so that would be 6.4 times 2. This is the length of AE, so this would be the total perimeter. So what I did, we added 6.4, 6.4, 2.715, this length and that length, that's why times 2, and the length of BD, that is 14.105. okay, so what would be the total length? So 2.71, the length was 2.71 551913 times 2, and then plus 2 times 6.4, so the total length is 32.33. it's an like infinite decimal value. So they wanted up till how many decimal places? 32.33603.826 meter. So they wanted up till, I think, 3 significant figures, right? They wanted to 3 or 1 decimal place. Okay, since they wanted to 1 decimal place, it will be same, 3 significant figure and 1 decimal place. So this is what? 1 decimal place, 32.3. Done. Next is what? Part C. In part C, they are asking to find the cross-sectional area of the entrance to the tunnel ABCDEFA in meter square to 1 decimal place. Okay, now our work is to find out the cross-sectional area of this tunnel. Okay, the cross-sectional area. So there are two congruent triangles, AFB and DFE. So if we find out the area of one of the triangle and then multiply it by 2, then we are getting what? Both of them. Okay, and then we will add what? The area of the sector BFD with that. So let's do that. So at first, what our aim? Our first aim is to find out the area of triangle AFB. Okay, so for part C, we need to find out the area of triangle what? AFB. So area of triangle AFB is what? Which formula we will be using? Half of AB sin theta, right? Half of AB. The adjacent sides are 6.4 and 6.2, and theta is what? Sine 0.4333 radian, right? So what's the value? 6.4 times 6.2 times 0.5 times sine 0.4333 radians. So the value, it's 8.3301 833.84 what? Meter squared. This is the area of triangle AFB. Okay, so since triangle AFB and triangle DFE are congruent, so we got that area. Now remaining is the area of the sector BFD. Okay, so sector area BFD. So sector area BFD, this is equals to what? This is equals to half of r square theta, right? Half of r square is how much? 6.2 square, and theta is how much? 2.275 radians, isn't it? Okay, so the value would be half of 6.2 square times 2.275. That is what? 43.7255 meter squared. So area, so total area we will get how much? Just add them up. So 43.7255 plus what? Twice of the area of triangle AFB. Okay, that is 8.33 something. 8.33. It keeps going. So what would be the total area? 2 times, so 43.7255 plus 2 times 8.33018334. So that would give you the total area, what? 60.385. Okay, it would give you 60.385 86677 meters squared. Okay, so 1 decimal place, isn't it? So that would be 60.4 meters squared. This is up to 1 decimal place. And that's it. That's the answer for part C. And that's all about question number 6 from May 2024 P1 regional paper. That's it.